This video will cover the CPM Algebra 2 textbooks lesson 112 day 2 review and preview problem set, which is problems 119 to 125. So problem 119. Jill needs to cut a piece off of a 30-foot length of lumber. We are to create multiple representations, so we need to make a table, a graph, and an equation for the function with x values that are the length of the piece Jill cuts off and y values are the length of the piece that is left over. Then once we create them, we're going to decide which representation best portrays the situation and why. When it says explain, that means a sentence or two. Okay, so let's delete that. Okay, so I'm going to start off with the equation here, and we'll do that first. So y is the length of the piece left over after you cut it. So y should equal, so we start off with 30 feet, then we subtract from it the length we cut off, which is x. So that would be the equation. And so I'm gonna pick some values here. So we're gonna start off with 0 for x. I'm gonna let the last one be 30. So when I cut off no length, I get 30 left over. When I cut off 30, I get 0 left over. So then I'm going to pick 10, 15, and 20 as my other variable values for x. So when I cut off a 10-piece length, according to my equation, I'll be left with 20. When I cut off 15, I'll be left with 15. When I cut off 20, I'll be left with 10. So now we're going to make a graph of this. So this is going to be 0. And so because I have the equation, we still do need to, however, label the axis appropriately. So x is the length of the cut. So length of cut. And then y is let's see here, the length left over. So the length left over, and both are being described in feet. So we normally put the unit of measure at the end in parentheses. So because I'm going up by kind of fives in both directions, I'm going to count by 5. So 5, 10, 15, 20, 25, 30, 35, 40. Do the same thing here. 5, 10, 15, 20, 25, 30, 35, 40. So when I cut off 0 length, I'm left with 30. So there's 30. 10, that's 10 gives me 20. So 10 is 20 there. 15 gives me 15. 20 gives me 10. Then 30 gives me 0. Now this is a segment, and we connect the dots because I can cut off any length of wood that is decimal or fractional, so we can connect those dots. But there's no arrows coming out the end because it doesn't make sense to have 0 length of a cut and a negative length of cut or negative length left over. So which representation best portrays the situation? Well, I feel like it's the equation, since we can easily see how the leftover piece is related to the length of the piece Jill originally cut. That's what I think. However, you might think the table and the graph are better representations, and if you do, you need to give a 1 to 2 sentence reasoning in proper English of why that is true, why you believe that is true. Okay. Problem 120. Make a table and graph of the function f of x equals 1/2 x squared. Describe all the possible outputs and input values. So again, I'm going to use the following values for x: -4, -3, -2, -1, 0, then 1, 2, 3, and 4. I'm going to start plugging them in and plotting points as I get those. So let's start with -4. I'm going to first square -4 gives me 16. I times it by half. Half of 16 is 8. So -4, 8. 1, 2, 3, 4, 5, 6, 7, 8. Plot that point. Now -3. So -3 squared is 9. Half of 9 is 4.5. So -3, 1, 2, 3, 4.5. 1, 2, 3, 4. About right there. Oops. -2 squared is 4. Half of 4 is 2, so -2, -2. -2, 2, sorry. So -1 squared is 1. Half of 1 is a half. So I'm going to use decimals. So 1 gives me a half. 0 squared is 0, and half of 0 is 0 still. So then 1, actually in the parabola, because 1 squared is the same as -1 squared, these values are just going to repeat themselves. And so when we get to chapter 2 in this curriculum, you'll understand why. So 1/2, whoops, that's pretty bad. Let's graph that, try that again. So a half's right here. 2 is 2. 3 is 4.5. And 4 is 8. Remember, one of our things in the book so far is plot points accurately when we graph, so we can graph accurately 4.5. So you need to do your best job to plot it. Now this is a parabola. It makes a U, so we start outside the coordinate plane. We try to, without lifting up my pen or pencil, kind of dots, you curve through the bottom point, back up. Hopefully your graph's better than mine on paper. And we always draw arrows, and the arrows for all of our graphs we draw should be outside the coordinate plane. So there's that. Now describe all the possible input and output. So if I want to describe all possible inputs, that's the domain. And the possible outputs, well, that's the range. So let's talk about domain. So as you can clearly see, this graph will open left and right forever, which means that eventually every value of x will be used as a point on this graph. In the equation, we can see that no matter what I plug in, I can always square a number. So we say the domain in this case would be all real numbers, and any value can be used. We call it all real numbers. So to describe that with inequalities, here's how we write this. So we go biggest to smallest. If I go left forever, I'll eventually get to -infinity. Okay, and I know x has to be greater than that. But if I go right forever, I'll get to infinity. So x also has to be less than +infinity. And since I can never equal infinity, which we'll talk about more in the next lesson, there's no equal to sign. So that would be the domain. And that is right there in words, we say that's all real numbers. So any number on the number line can be used in this equation. Now the range, we can clearly see this graph does not go up or down forever, but it does go up forever. So we're looking for that lowest y value that exists on the graph, which is right here. That's the point 0, 0. So this right here is the lowest y value, which means because the graph goes up is increasing in the y direction. We say y's have to be greater than 0, but since 0 is on the graph, we also let it equal that. So remember, the domain is all possible inputs. So when we describe that, describe inputs, that is the domain, and the range is all possible outputs. So we want to start to equate that verbiage to domain and range. Okay? Okay, 121. Given f of x is -2/3 x plus 3, and g of x is 2x squared minus 5, we're going to use these functions to complete parts a through f below. So a is calculate f of 3. So remember, when I have f of a number, that means to determine the value of that function when x is 3. So f of 3, function f is the negative 2/3 x plus 3. So we're going to actually plug in for the x that 3, and then evaluate that. So 2 times 3 is 6. 6 divided by 3 is 2. That's negative 2, then plus 3. And negative 2 plus 3 is positive 1. So f of 3 is 1. Solve f of x equals 5. So when the f of x notation is equal to a number, we need to set the rule equal to that value and solve. So this is an equation with a variable, next to a fraction. So anytime I have a fraction in an equation to get rid of it, I simply take the entire equation and multiply everything by the denominator, which is 3. So negative 3 times 5 is negative 15. So negative 2/3 times 3, so negative 2 times 3 is negative 6. Negative 6 divided by 3 is negative 2, so you get negative 2x. 3 times 3 is 9. So we'll solve that. We'll subtract the 9, so that gives me negative 24. And divide both sides by negative 2, so I get x equals 12. So C, g of negative 3, and now we're going to use 2x squared minus 5. And so, again, now that we have an x being squared, or an x, the variable to an exponent, is doubly important. We put that plugged in value in parentheses. So here we go. Negative 3 squared is 9. 9 times 2 is 18. And 18 minus 5 is 13. So there's that. Okay, now we'll go g of x equals negative 7. So same idea. Take what g of x is and let that equal negative 7. So we'll add 5. So we get negative 2. We'll divide by 2. Now here's a problem. X squared equals negative 1. But when you square a number, you only get a positive result. So this is not possible yet. So we say whenever x squared equals a negative number, we say there are no, and this is important, no real solutions to this problem. There are solutions, they're just not a real number at this point. Okay, g of x equals 8. So we'll do it again. 2x squared minus 5 is now going to equal 8. So we're going to add 5 to both sides, which gives me 13. I'm going to divide both sides by 2. I'm going to leave that as 13 over 2. That's positive, so to undo the squaring, we're going to square root. Here's a big idea. These cancel. But anytime I square root to solve an equation, the side that was not originally being squared, you have to put a plus or minus sign in front of the square root. That implies there are two possible answers. X can be the positive square root of 13 over 2, and x can be the negative square root of 13 over 2. So we really want to emphasize this plus or minus sign when we solve these types of equations by square rooting. So g of x equals 9. So let's do it again. So same function equals 9. So now we're going to add 5 again. Divide by 2. It's going to be 7. And again, we're going to square root. So square root both sides. The square and the root cancel. So let's do that properly. X, and then I'm left with root 7. So I got to put that plus or minus sign in front of it. So the solutions are x can be positive root 7 or the negative square root of 7. Okay, 22. Jerry made a function machine. Below are her 4 pictures of her machine. So you know inputs are on the top. So these are the x's. The bottoms are the y's. So based on that, let's see if we can determine a relationship between them. So what do I do to each x to get each y? So first off, let's start with negative 1 and negative 1. Well, I can take negative 1 times 1, and that gives me negative 1. We can see that, 3 times 1 isn't 27, so that doesn't work. Another way I get negative 1 is if I cube it. So negative 1 cubed is negative 1. So let's see, 3 cubed, that is 27. Negative 2 cubed, that is negative 8. 0 cubed, well, that is 0. So since it's a function machine, we should use the notation f of x. And it turns out f of x is y. Same thing. Okay, those are the same ideas. And it turns out if we take the x's and cube it, I get the y's in the picture. So the function machines is f of x equals x cubed. Okay, 23. Examine each graph below. Based on the shape of the graph and the labels of the axes, write a sentence to describe the relationship that each graph represents. Then state which axis represents the independent variable and which one represents the dependent. So you can see that the first one has gallons of gas to dollars, and it's a line. Lines increase constantly, so we say that the price of a gallon of gas increases constantly. Could also say as I get more gallons of gas, the amount increases constantly. So this word constantly is important. The independent variable is x, so it's the gallons of gas. So it's really important that you write exactly what the axes say. The dependent variable is dollars, or the amount you're going to spend on that gas. Okay, B is age and the height. So it seems like I would say people grow rapidly when young and slowly as they get older. We can see how at the beginning I have a rapid increase and I steadily increase and stop growing at some point. The independent variable is age. Remember, age is sort of like time, and so time is always independent. And the dependent variable is the height of somebody, and it's in inches. Okay, C is year and levels of ozone concentration. So this just looked familiar. In the previous class, we should recognize that as exponential. So we would say the levels of ozone concentration decrease exponentially every year. Okay, because exponentially will level out eventually. The independent variable, again, years, is a value of time. Time is always independent, and dependent is the levels of ozone concentration. Okay, so D, number of students and number of classrooms. So it looks like every classroom, you see how it's a step graphic, and so from 0 to 1, 30, 0 to 1 to 2, 60. So it seems like that only 30 kids can fit in a classroom. So we say that. We say something like for every 30 students, another, so other, sorry, so let's write that, and we'll delete this, and other classroom is needed. So since number of students determines how many classrooms, the independent variable will be number of students, and the dependent variable will be the number of classrooms. Right. Okay, 123, part E. What are all the possible inputs of the graphs of part D. So I put the graph back here and output. So again, possible input. So it wants me to describe the domain and it wants me to describe for possible outputs the range. So let's talk about domain. So it looks like the number of people here is constantly increasing, but we have to be really careful because we can't have decimal values of kids, right? So the domain is going to be 0 to infinity, but we're going to count by 1, 2, 3, 4. So those are the whole numbers. So we say the domain is the set of whole numbers. Another way to describe that is with the set notation of 0, 1, 2, 3, dot, dot, dot. It kind of tells people how we're counting. We use this notation, this brace notation, when describing sets of numbers like that. And the range is very similar. You see how 0, 1, 2, 3, 4. So it's the same exact thing. Now, there will be some debate as to whether the domain should be all real numbers, but because students can't be decimal values, I argue it can't be all real numbers. And so the domain and range is the same because this graph keeps growing. And so I'd say the domain and range would be all the sets of whole numbers because 0 is included. Okay, 124. Consider triangles ABC and AED at right. So ABC, the small one, so let's highlight that. So ABC, and then we'll do the other one in green, ADE. Whoops. So let's highlight this. So, whoops. So ADE, so you can kind of see the differences there. And we're told that they are similar. So we know from geometry that similar triangles have congruent, so have proportional corresponding side lengths. So you can kind of see these sets. So use what we know about the similar triangles to complete each of the following ratios. So x and y, so x is the height, and so y is the height, x is the length of the small triangle ABC. So in this problem, I do heights to heights and lengths to lengths. So since n is the height of the big triangle, we'll put an n here. And since m is the length of the large triangle, we'll put m here. So n over m is what we should write for part A. Then B is n over y. So n is it's height to height. That's really important. This is the big triangle and y is the small one. And so, and this has to do with, so ny is the heights. And so this should have to do with the base lengths. And again, this needs to be the big base and this needs to be the small base. So the big base is m, so we're going to write m first. And the small base is x, so we're going to go m over x. Okay, last problem. Note the stoplight icon, so this guy right here, to the right of the problem indicates that there is an error in the problem. So throughout the core problems and homework we cover, when you see that there's an error, and usually what you're going to be tasked to do is to identify the error, explain it, and then correct the problem, showing how to do it correctly. Let's see if we can figure this out. So we have in this problem, looks like to get from step, all numbers, step 1, 2, 3, 4, so we can kind of be on the same page here. So to get from step 1 to step 2, it looks like they distributed. So let's make sure they're distributed correctly. 3 times x is 3x, so that looks good. 3 times negative 2 is negative 6, that looks good. Negative 2 times x is negative 2x, that looks good. Negative 2 times 7 is negative, oh, that's wrong. And so the error is, they did not correctly distribute negative 2 times negative 2 times x plus 7. So let's show how to do this. We're going to redo the problem down here. Let's redo this correctly and make sure we get the right answer. So here we go. So we'll distribute through correctly. So we get 3x minus 6. Negative 2x minus 14 gives me 2x plus 17. We simplify both sides, so combine like terms. So we're going to combine the x's and the numbers on the left. So 3x minus x is 2x is x. Negative 6 minus 14 is negative 20. That's going to be there. So now we're going to collect variables on the same side. So I like to move the smaller x value because it's always going to result in a positive x as the sum are different. So I'm going to move the x on the left over to the 2x by subtracting it. So 2x minus x is x. And so since x is on the right, I got to move the numbers to the left. So I'm going to subtract the 17 over. So negative 20 minus 17 is negative 37. So that's what I think. So to check my work, we're going to plug that in. So we're going to go 3 times negative 37 minus 2 times negative 37 plus 7 should equal 2 times negative 37 plus 17. I'm out of room. Let's put this in a calculator. So on the left hand side, 3 times negative 37 minus 2 parentheses minus 2 times negative 37 plus 7 in parentheses gives me negative 57. And if I'm right, I see the same thing on the other side. So 2 times negative 37 plus 17 gives me negative 57. Those are both the same answer. So my correct answer is negative 37. All right, so that does that for this set of problems. If you found this video useful and helpful, please like it and consider subscribing to my channel for as I add more videos to my playlist for this Algebra 2 curriculum.